Welcome to Cronitide Education. Our today's chapter is Mathematical Logic. Mathematical logic is a very simple and interesting topic which helps us to determine whether or not a given statement or a group of statements hold true or false under given conditions. First, we need to understand what is a statement. An assertive sentence is called a statement. For example, a month has 35 days. This is a statement. This statement can either be true or false. This is called the truth value of a statement. If a statement is true, it is denoted by capital T, and if a statement is false, it is denoted by capital F. These statements can be symbolically represented by lowercase letters such as P, Q, R, etc. A statement is also called a proposition. A proposition can be of two types, simple proposition and compound proposition. A simple proposition is one which cannot be split, whereas a compound proposition is one which can be split into two. For example, a simple proposition is 2 is a prime number, whereas a compound proposition is 2 is an even prime number, which can be split into 2 is an even number, 2 is a prime number. Two simple propositions can be connected by connectives. Today, we are going to learn about 4 different types of connectives. They are or, and, if, then, if and only if. Or is represented like this, and is represented like this. If then is represented like this, if and only if is represented like this. First, let us understand how do we read the following connectives. For example, take two statements. Over here I have taken P and Q. Statement P reads that 2 is an even number. Statement Q reads that 2 is a prime number. If it is P or Q, that means if these two statements are connected by or, it will be P or Q. That means 2 is an even number or 2 is a prime number. If these two statements are connected by and, 2 is an even number and 2 is a prime number. If these two statements are connected by if then is also called as implication. If these two statements are connected by if then, you will read it as if 2 is an even number, then 2 is a prime number. If P, then Q. If these two statements are connected by if and only if and only if is a double implication. This will read as 2 is an even number, if and only if 2 is a prime number. This means that P if and only if Q. Constructing truth tables is the most important part of this chapter. All the sums are more or less dependent on this. Now we will learn how to construct truth tables. So first I have taken P or Q. That is, I have taken the connective or. To construct the truth table, we need to first write proposition 1, proposition 2, and then the connective proposition. Remember these easy steps to make solving mathematical logic simple for you. Under your proposition 1, you need to write T, T, F, F. T stands for true, F stands for false. So you write T, T, F, F. Under Q, you write alternately T, F, T, F. Now when we are finding out the connection between P or Q, when the connective is or, even if one of the statements is true, your P or Q will be true. So P and Q, even if one is true, this will be true. Even if one is true, this will be true. Even if one is true, this will be true. Since over here none is true, this will be false. So remember, if you're finding the connective of P or Q, even if one of the statements is true, your compound proposition will be true. If both the simple propositions or even one of the simple proposition is true, your compound proposition will be 2. So first write TTFF, TF, TF. Then even if one of them is T, your answer will be T. If both of them are false, it will be false. This is the case for P or Q. Let's move on to the connective AND. So here I have written P and Q. Remember the first step, you need to write TT, FF, TF, TF. This is very important to remember. Now, in P or Q, even if one is true, you write the answer as true. But in P and Q, both have to be true for it to be true. So here both are true, therefore it is true. Only one is true, so false. Only one is true, false. Nothing is true, so false. Moving on to the next connective, if then. If P, then Q. So remember, our first step will remain the same irrespective of the connective. So we have TT, FF, TF, TF. Now this connective if P then Q is a little tricky. You need to remember if P is true and Q is false. If P is true and Q is false, then the answer